right. Checking my audio inputs again. They're good. Yeah, that sucked. Okay. In order to induce electrical energy into a conductor, 4 minutes of no audio. Shit. Into a conductor or generator, what three factors must be present? Well, we've got conductor, heat, magnetic field, relative motion, rotation. You need to have a conductor, you need to have magnetic field, and relative motion. Induction is calculated by however many times a conductor cuts through the lines of flux in a magnetic field. For it to cut through, it has to have relative motion. Yes, phone, I have heard. Okay. So that gives us 1, 3, and 4. This next one is frequency, as a measure of how often a waveform is completed in relation to time. That frequency, that's how many cycles of the sine wave in a second. So it's all the way up, down, and back. There is a formula to look at on page 34 that we will get to on some of the last questions, questions 7 and 8. Use that formula. We will get to that whenever we get there. Excuse me. Identify the brush in the figure of the simple generator below. The brush is at D. See, that's got the arrow. That little square cube looking piece rides on the slip rings, which are these rings that are labeled C. So we got D. Next up is the armature windings. So if you look, B is pointed at these slightly grayer lines. Oh, that's better. So B is pointing at these slightly grayer lines on the screen. And that's the windings of the generator. A is going to be the magnetic poles. Yeah, magnetic field poles is A. That's the north and south. I sure hope y'all did good on this one. This one seems pretty straightforward, right? You got a huge north and south labeled. Oh, that's good. 2 of you. We can chalk that up just to mistakes. Identify the slip rings. So that's these. In a AC generator, you will have one side of the windings connected to one slip ring and the other side of the windings connected to the other slip ring. The brushes ride on the slip rings and pull the electricity off. Okay. The output of a 2-pole generator rotating at a speed of 3,600 RPMs would be blank hertz. All right, so on page 34, I hope there's enough light for you guys. If you look, there is a formula right here. And it is 120 times frequency over number of poles is your speed. So let me open up Paint. And let's get that written down. Okay, so we have speed is equal to, let's go back. Speed is equal to 120. This 120 is a constant. It's not a, am I broadcasting double? This is annoying. I certainly hope that's better. Okay. Hopefully that was only for a couple minutes. 120 times frequency over 120 times frequency over number of poles. So 120 times frequency over number of poles. The question we were given was the output of a two-pole generator rotating at a speed of 3,600 RPM. So we know 3,600 equals 120 times F over 2. This should be pretty simple to work out. Like I was saying, if you look on page 34, it will explain right in here. It says synchronous speed is the exact speed the generator must spin to develop the desired frequency output. We were given the speed, so we're going to work backwards from there. 120 is a constant that results from converting cycles per second to revolutions per minute, a factor of 60, and converting the number of poles from actual pole faces to pairs of poles, a factor of 2, yielding a constant conversion of 120. Frequency is measured in hertz, and number of poles will be an even number. So 2, 4, 6, 8, something along those lines. All right, so with this, we're going to multiply both sides by 2. Let's multiply both sides by 2. That will cancel on this side and give us 7,200 equals 120 times F. Now we'll divide by 120. Divide by 120. I can't do that one in my head. We'll open up a calculator. $7,200 divided by 120 is 60. Minimize that. So we end up with 60 is equal to F, or frequency. So that gives us, the answer is 60. Come back here. See how we did? We got 56%. All right. Now that we're done with the book, well, we're not done with the book, but we've learned the thing out of the book. All right, so now let's go back here. The answer is 1,800 RPM on this one, and I did show an explanation. Here is that, oh, that's tiny. Here is that formula, and you can see they plugged in the numbers and got the RPM. I will work that in Paint. Just give me a second. Okay, so we have 60 hertz and 4 poles. So we have S is equal to 120 times 60 divided by 4. I wrote 6, meant to write 60. All we need here is a calculator. Clear. So we have 120 times 60 divided by 4. 1800. That is 1800 RPM. That was 60 hertz. And that's it. That's all you needed to do. We are right at 15 minutes, even though I had to repeat myself. I will be editing this video for sure. All right. Oh, and it's 1:59, so perfect timing. I will be putting up the next quiz in a moment. I will see you guys in a couple hours.